All right, so we are recording. We are live. So what we're going to go over today is we are going to go over flow control. Now, what flow control is controlling the flow of our code. And what does that mean? I need to erase all this. Means so far we've basically only done letter or variables and numbers is about all we've done. So, oh my gosh, this is what I get for not erasing in between classes. Okay, so here's a diagram from our book. It is supposed to be on the TV. Is the TV not on? Oh, well, that would help. And don't forget, I'm not going to forget to share it, Will. I remembered this time before you told me. I'm getting so good at this teaching thing. Okay, so this is a diagram, a flow chart for your code. Oh, and one other thing. I know, at least in the other class, you guys go on the internet or play games on your surfaces while I'm teaching, and you're supposed to not be doing that. So, if I see it once more, I will just disable Wi-Fi for this class. You guys will come in, your Wi-Fi won't work. When you leave, it will. So, I don't like doing that, but I will. So please, 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 don't be playing games. Don't be going on Facebook. Don't be watching YouTube with it muted or whatever. Please just, while you're in here, pay attention. Okay? Cool. So, so this is a, yes? I don't even know where it went.
Maybe they took it back to the screen.
They might have.
Wait, didn't you throw it out last time though?
I have no idea what I did with that thing. Whatever.
I thought you threw it and then you missed.
I might have.
Well,
That also
yeah,
might have been my
that's
cup.
right. You did.
I don't know, but we're getting distracted. So a flow chart allows you to kind of give yourself a rough draft of what your code's going to do. So this is a flow chart for deciding should I go outside or not. So we start obviously here. I'm going to start with red. Now, how many ways are there to go through this flow chart? We go, is it raining? Yes. Do we have an umbrella? No. We wait a while. Is it raining? No. Then we go outside. So that's one way we can go through this. How many ways can we go through this flow chart? Who says more than 5? Who says infinity? Infinity is not the answer.
Wait, well, is it different if you go loop back a different number of times each time?
No, it's the same.
Okay, well then.
I got a 3.
Then it's
4. 4. I got a 5. So let's go through. I'm going to use a different color each time. So we start off our
actually, yeah, but
we start off our code and we go down. Is it raining? Is it raining?
no.
We go outside. End of the code. We start. Is it raining?
Yes.
Yes. Do we have an umbrella?
Yes.
Yes. We go outside. We start. Is it raining? Yes. Do we have an umbrella?
No.
No. We wait. Now is it raining?
No.
We start. Is it raining?
Yes.
Yes. Do we have an umbrella?
No.
No. So we wait a while. Is it still raining?
Yes.
Is it still raining?
Yes.
This counts as one thing. So no matter how many times, that's one path. And then we go no. And we that.
So it is 4.
So it is 4, right? There's only 4 ways. Currently, we only know one way to do code, right? Variables, math, display, what else? Oh, and speaking of, for your quiz, I would, I'll explain that, but don't let me forget. There's something I want to explain about your quiz before you guys leave. So there's 4 ways to do this. to go through this. With if statements, we are going to have that ability. We're going to be able to say entire sections of our code won't get written, won't get executed because do you want to go out, is it raining, yes or no? If it's no, then we're not going to, if it's not raining with our red, all of the code over here doesn't get used at all. And that's okay. So, and then there's actually a little bit of an issue with this one because this would actually be a loop, and we're going to learn that later. But with our flowcharts, there's actually each one of these boxes has a different meaning. So anything that's a circle is a start or end point. You only have one of each in your code. Diamonds, this is flow control. Notice every decision-making point is a diamond. Then we have rectangles. Nope. Okay, that's actually, we're going to go with a rhombus. This is for inputs and outputs. And then just a, there we go. This is for calculations. So will you have to use these? Probably not too much in this class. I recommend writing things down before you start coding, even if it's something simple. Like, just write out the steps, especially for your video game. You know, I want the bad guys, make bad guys go across screen. Well, in order for bad guys to move, they need a starting point. So starting point. And then determine speed, you know, how do they move across? So it's just writing out even just steps of what you want to do can be very, very helpful. There are times when I'm helping students with their final project that I have to take what they're writing, what they're doing, write it down so that, one, I can better visualize their code because it's really, really hard to visualize code in your head. Like, because at that point, it's just, it's words. Like, there's not, yes, Anna?
What does it say?
In the flow control.
What does it say in the rectangle?
Calculations. So this is start, end. Flow control, so this is if statements. So this is what we're learning today is if. Also loops, but we're not learning that today. Input, output, this is print or input. And then calculations is like x is 10 plus y. Yes, Brandon.
So for the input functions and the input functions, do they do the same thing? Or
No, it's just in the loop. That's just an input output. That's just the thing they use. So no, they're not the same thing. Print takes something from the code and shows the user. Input takes something from the user and puts it in the code. So in general, this is about as much as I'm going to ask you on a test or a quiz. Closest thing might be, of the following, which one is not used in flowcharts?
The circle?
Triangle.
Oh, where's the circle? I don't see it. Oh, start?
Starting and end.
Oh, okay.
So do you guys have any questions on that? No? Okay. Then I can hear my computer heating up, so I'm going to close that.
Sorry, the start did not look like a circle.
A circle, oval thing. Okay, so what we're going to do today, though, what we're going to continue on, hang on, I got to get all my windows over here so I can see what's going on. Can you guys give me the 3 data types that we've learned in class? Asher, give me one.
String.
String, yes. Lorian.
Float.
Float. Anna. Yes. We are about to learn a new one called Boolean.
Ooh.
So Boolean. A Boolean variable, also called bool in, if like in errors and stuff, it'll say bool. Because you know how we have str for string, int for integer, bool, see how it changes? So, actually, I wonder, whatever, I'll deal with that later. Booleans can have, how many options are there for an integer variable? Asher? Infinity, yes. How many for a string, Lorian? How many variations of a string variable can we have? Infinite, yep. With a Boolean, it's 2. Any ideas? True and false, yes. So we can have, so we're going to start with rain is true or rain is false. So as soon as you type, it gives you a Boolean. So again, really hope it didn't just break something. Again, a Boolean variable can only have one of 2 values. It can either be true or it can be false. Does that make sense? Okay. Actually, I should probably open the book. Actually, no, I got what I did here. So the other class asked, well, when are we ever going to use this? I know a perfect place to use this. It's perfect to use when, especially in your video game, if you have power-ups. So who here has ever played any Mario game ever? Mario? It's me, Mario. You never played it?
Mario Odyssey's good.
Dude, you're missing out. It's so, especially the originals. Anyway, so there's a, do you know the fire? He can shoot fire? Okay. So in your game, you may have a power-up, right? Does Mario start with the fire breathing? No, he starts as like this short little guy. So you can start fire power-up is false. So he starts with this attribute false. He doesn't have it. Then something happens. Okay, that's more code in the game. Something happens. And then you have fire power up equal true. If fire power up equal true, then print Mario is on fire.
Well,
Right, so don't ignore everything except this. Right? So you can set it up to where if this is true, do something. Now, you can also, instead of using true and false, just use ones and zeros. So if it's easier for you to think of something as false being 0 and 1 being 1, false being 0 and true being 1, you can do that too. It's just...
that's a little more confusing because what if you actually wanted to set a variable to 0? Because then you get mixed up with like...
That's a very good point. So I'm just saying, it's easy to think of it. True is 1, false is 0. Okay, 1s and 0s. Boom. So, does that make sense? Okay. One thing you can't do is this, right? So if we do Mario equals true, what does that mean?
It's treating it like a variable, not a base.
Exactly. It's treating true like another variable. Have we defined true as anything? No. So we can't do that. So Mario has to be true like that. And we also can't do true is 2 plus 2. You can't assign something to true. But you can assign true to something. Does that make sense?
Yeah.
Are you sure? Kind of confused me, so you guys are smarter than I am. But that, so obviously true can't take on its own value because true is the value. So now we're going, you guys, go, scoot down. Right, dock it to top now. So true, so you can't do that. Who here has done, you guys know the greater than, less than signs, right? These things, you know, 6 is less than 7. You guys are familiar with that? Okay, so Python evaluates that and comes out to true, right? Because is 6 actually less than 7?
Yeah.
Yes. Is 6 greater than 7? So what do you think is going to pop up? False, exactly. So you can use these to determine whether or not a number is positive, if it's negative, if the user typed in the password correctly, if they didn't, that sort of stuff, and we're going to learn how to do that today. We're going to continue with this. So, oops, that's not what I wanted to click on. So we have greater than and less than. I'm sorry, less than or greater than. So again, 6 is greater than 7. It's false. But 7 is greater than 6 is true. 5 is less than 6. 5 is less than 10. Let's do this. 3 is equal to 3. Am I going to get an error with this? Why do you say yes? Yes. We can't assign a value to a value. That's what the one equal sign is. This variable has the value of this. Whereas if we have 3 equal 3, this is does 3 equal 3? Is 3 the same as 3? Is it?
Yeah.
So we'll get it true. So this will actually happen. I do this quite often. I'll do something like if 3 equal 3 print, oops. So then I have to go back and equal. It's a very common mistake to forget to put that second equal sign. Oops. Come on, there we go. Questions so far? No? You can also assign x to equal 3 greater than 6. So what does x equal now?
X equals 4.
X is false, yeah. So you cannot do 2 equals 2 should give us what?
Error.
What?
Error.
Correct. 2 double equal 2 should give us true. Now what if we did 2 equals 2.2? What are we going to get?
False.
Correct. Now here's the kicker.
True. Because it's an integer.
Guys are killing it. Okay. Okay, so we've gone over this, gone over that, gone over this. You guys have any guess as to what does not equal? What symbols we use for 2 does not equal 3?
Exclamation equals sign.
Who said that? Did you know that or are you guessing?
No, I did that.
Didn't you already tell us that though?
I don't know.
Yeah, I think you did. I think you mentioned it.
Oh, because that's right. Because someone was like, "Why can't we use a exclamation point?" I'm like, "No, that's for something else." Right?
Yeah.
My 2 classes blend together, so I'm really sorry.
No, you're good.
Anyway, so yeah, does not equal is the exclamation point equal. So does 2 equal 3?
No.
Or is 2 not equal to 3?
Yes.
So this is true. What if I did 2 does not equal 2? If I could type.
False. False. Right?
Mm-hmm. The last one. Sorry. This is the last one. So let's do this. What is this? What's the answer for this one? 2 greater than 2. But they're the same number.
2 can't be greater than itself.
So what if I did 2 greater? So what do you think I add to this to see if it's greater or equal to 2?
Equal sign.
Equal sign. Correctamundo. 2 is less than or equal to 2 is still true. So a way to figure out if something is positive. So a lot of stuff with numbers, you can do it 2 different ways. If I wanted to say a number was positive, I'm going to assume it's 100 is greater than 0, right? I could also do greater or equal to 1 if we're doing a whole number. If we are doing 0.1 greater or equal to 0, that'll work. Oh wait, no, hang on, I want to do it this way. So 0.1 greater than 0, right? Should give us what?
True.
True. 0.1 greater or equal to 1 should give us
False.
correct. So with positives, you got to be careful if you're doing decimal or whole numbers. Typically, it's better greater than 0 as opposed to greater or equal to 1. Because there's literally an infinite number of numbers from 0 to 1. Which is a different type of infinity than from 0 to infinity.
One's countable, right?
Yep, one's countable, one's uncountable, or whatever. Because 1, I always know the next number, 1 to 2, 2 to 3, 3 to 4, till the end of time. But do I go 0.1 to 0.2, or do I go 0.112, or do I go 0.1111? If I start at 0, what's the next number if I'm doing decimals?
0.0000000.
Wrong. Exactly. So that's why it's uncountable infinity. So just a fun little fact. Okay. Any questions so far? With yes, no's, maybe so's. Cool. Now we've been doing all this stuff with numbers. We can also do it with strings. Is hello the same as hello? Is this true or false?
Oh, I didn't see the capital.
Why? Lori? Oh, Kevin? Yep. Capital H is different in computing code in binary than it is than lowercase h. So things break down. Who here knows what ASCII is? Okay, so I don't know what it stands for. American Standards and Computing is something like that. I don't really know. But what it means is that everything on your keyboard has a value other than what's printed on the key. Because everything in your computer breaks down to a 1 or a 0. So what is K in binary? Well, you can only... Oh.
I used to know.
If you knew K in binary, because you'd have to know what 107 is.
I know like the, and you say like,
Well, regardless, so you can see that everything on your keyboard has been accounted for. Space, exclamation point, the @ sign, capital letters, lowercase letters, symbols, all this stuff. And the reason that is because binary has to deal with 1s and 0s. You can only do binary with numbers. So you have the letter K has to be assigned a number in some way that can then get broken down into binary that can then be processed by your computer processor. So they came up with ASCII, and A is 97, lowercase a is 97, and uppercase A is 65. So to a computer, hello with a capital H and a hello with a lowercase h, are two totally different things. As opposed to us, where we realize that the person probably means the same thing. Right? That's why texting, if you don't capitalize things, people don't freak out. Like you didn't start the sentence with a capital letter, end it with a period. I have no idea what your sentence is saying. No, but to a computer, it needs to have. Listen, the beginning of a sentence has to start with an H, or it has to start with a capital letter, has to end with some sort of punctuation, or it's not a sentence. Humans, we don't need that. We're like, whatevs. Right? I think I told you, or it might have been at Parents' Night, computers are dumb. They can only understand two things, ones and zeros. Everything gets broken down to a 1 or a 0, and then dealt with, and then built back up. So, and they only do what you tell them to. So there's a lot of times when it's like, you're not doing what I said to do. And it's like, yeah, I'm actually just literally doing everything you said. You just don't know how to talk to me. So, and you can kind of think of it, so this is a really easy way to do alphabeticalize stuff. So if you want to write code that will automatically alphabetize things people type in, you use these relational operators, less than or greater than, because what'll happen is the words get broken down into these numbers. Okay, so if you just type in an A gets broken down to 65. The lowercase a gets broken down to 97. To flip through, you can think of it this way. This number is how many pages in the dictionary you need to flip through to get to that number, to get to that word. So if I have to flip 65 pages in a dictionary to get to capital A, but to get to lowercase a, I have to flip through 97, which word comes first alphabetically? Capital A. Because the dictionary starts with A's and then B's and then C's and then D's. So the further the more pages I have to turn to get to what I'm looking for, the further along it is in alphabetical order. Does that make sense? So a word on page 100 in the dictionary, you can know comes before or starts with a letter before whatever word comes on page 400. You don't even have to know what the word is. You just know dictionary is in alphabetical order. So the sooner it is to the beginning of the book, the more in order it is, the higher whatever. Make sense? Any questions on that? Seriously, not one question?
I don't know. I'm still trying to process it all.
Oh, wait till we get to logic. Wait till we get to the next part. This part said it fried their brain. So,
Is it like A equals B so that B equals A equals
can you speak up a little bit?
Is it like A equals B and then B equals A and then you like if A equals B equals C then A equals C?
So you're talking about like A equal, yes, like that.
Oh, okay.
We didn't have last year.
Yeah.
Yeah, we're going
we
like,
won class, so I know what you gotta know.
what does that evaluate to?
True and true.
Is,
True.
so we're gonna do more of that, but it gets a little crazy. So let me just, so what you can do with comparing strings like this, you can do rain is input Is it raining outside?
Yes.
Yes. So if rain equal yes, print
What would you do true? Oh, this is
So you can take something the user types in and see if it matches something. It's very similar to like, you know, if you're listening, if you like an Alexa or a Siri, if you say, "What is the weather in my area?" one of the keywords she hears is weather. And so if user input is or contains the word weather, it runs the weather. It doesn't listen to every single word you say. It listens for very key words. So that's why sometimes when you go, oh, Alexa, can you, or I'm trying to think of something really obscure that I've asked. I don't know. I can't think of anything. But it's like, there are times when you ask Alexa or Siri something, they go, I'm sorry, I don't understand that. Because you either gave it too much information and it freaks out, or none of the things you said had a specific keyword that allows it to do something. So weather, temperature, is it going to rain? Is it going to be sunny? There are like a dictionary of words that if you say and Alexa hears, it will run the weather. Or it'll run a different, what's the weather in this area? Well, you said the word in and you gave a city, so it does the weather in that city, not where you are. Yes?
For yours it printed, for mine it didn't, and mine is exactly the same as yours. That's
What-
because he's in the shell, right? No, I'm
Did you
in
do
the
this?
shell. I did all of that, and then I did if rain equals yes. Print is raining outside. It
Is
the exact
that
same
word the exact same as that?
Yes.
Did you put the colon?
Do you have the colon?
Oh, did you space the print correctly underneath it? Uh-huh.
You have to press enter twice.
I did?
Oh.
I don't know why I didn't see
Are
that.
you,
Maybe
are you
I'll-
still underneath the print?
Yeah. It's exactly the same as that, I can assure you. I'll just rewrite it and see if it still does it.
Okay. We're going to keep going. So you can see, obviously, you can do rain is yes. Oh, oops. Rain is true. Yes, equal. Yes. Rain equal rain. All these things. So if whatever the user types in matches something, you can do something. This is exactly how databases work, or like when you log into something at work or Facebook. They have a dictionary. They have a list of every single user in their database. So you type that in, blah, 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 and then you type in a password, and it takes, if the username is in our database, awesome. If the password matches that user's password, let him in. Otherwise, say access denied, which is something we're going to go over at the end by the end of class. Do you guys have any questions so far?
Nope.
Okay, so now we're going to get into comparison. So x is 1, y is 0. Tracking with me? X equal y, true or false?
False.
X equal x. Oh, true. Y equal y.
True.
Y less than or equal to x.
True.
Yes, I did greater than. You guys were all right. These are comparisons. This is an expression. This is the value of that expression. Now, watch this. What's the answer? What's the value of true and false?
False.
Can I both be 0 and 1?
No.
So I'm false. Does that make sense? If I did true and true,
That's true.
can I be 0? Can I be 1 and 1? True or false? It's true, because can I be a 1 or a 0? Yeah, okay, that works. False or false?
True.
Asher?
Well, that's true, but I have a question.
Yeah?
Oh, it's false. But if you have a if statement, I know in JavaScript, You don't have to say like if rain equals true. You can just say if rain, and then.
Yeah, but that's only if you're dealing with true or false.
Yeah, with Booleans.
Yeah. Well, yes, you can. I just don't do that because it's really confusing,
Okay.
and it doesn't.
And then for false, you can say if exclamation mark rain. Can you do that?
I don't know exclamation point rain, but you do if not rain.
Oh, okay.
But again, I don't recommend that because it tends to confuse people. So, I'm going to go over a little thing. The only way something with and is true is if everything is true. Anything else is false. So, true and false is going to be false. True and false and true is going to be false. The only way anything with an and is true is if both things are true. Okay? Yes?
You guys just told us to make things false, like in logic, like till the true and false equals true.
No, it's not true and true.
Oh, okay.
Not true is false.
I
And
got that.
but we haven't gotten there yet. So this can be a little confusing. So we're going to go. So let's just do 1 = 1 and 2 = 2. That should be what?
Should be true.
True. The way this works is numbers. So that gets evaluated first, then this, and then the whole thing is once. It's the order of operations. We found this out first hour because I didn't realize that. So it's kind of like if you were to do, what's the answer? 35, yep. But that's because we know order of operations. If you didn't, you'd be 10 plus 5 is 15 plus 5 is 75. When the answer is 35. So it's the same thing. If you have this, it evaluates this first, then this, and then it does it all together. I don't think I'll quiz you on that. So the closest thing would be, here's a really long expression. Is it true or false? So it's always a 50% chance of getting it right. Yes.
I can't run my code. Do you know why it's not working?
Yes. You have to figure it out on your own though. What's wrong with it?
I don't know. It doesn't give like a syntax error. Just I click run my film and it does nothing.
Are you displaying or printing anything?
Yeah.
Because you shouldn't be in your console. You should be in the shell right now.
No. I'm in the console.
And I just said you shouldn't be. You should be in the shell.
Okay, but what if I want to run a program?
But we're not writing program right now. We're just doing value expressions or whatever. I don't know what to call them. Do you guys have questions so far? So if we were to do false and false = false, what gets evaluated first?
False.
False and false, so which is?
True.
False.
So it because if we did false and false is false, so if it evaluated false and false first, we would have gotten false. So then this would be false and this would be false = false, which would be true, but we got false. So it did it the other way. It evaluated this first. False and false. False equals false is
True.
false and true
False.
because
You have to have both true.
everything has to be true with and. in order for the expression to be true. Yes.
Well, so how could you make it that false and false equals false? How would you make that true? Could you just put parentheses around the false and false?
The easiest thing would be to do this. That's the easiest way. Like I'm sure there's a probably slightly more elegant way to do it, but that was the first thing that came into my head.
Wait, why couldn't you put in parentheses false and false?
You should be able to do that, and it should come out as true. Because it'll evaluate things in the parentheses first, which will come out as false.
Yeah,
So
why-
false equals false, it's just true.
If it is not,
That's exactly the look everyone else in the other class had.
It's like, this is just so. I mean, not quite easy. You're
Like,
writing
I
the same
understand
thing over
it,
and
it's
over
just
and over
like-
again. It's just like
It's not the way we think. We don't necessarily think in trues and falses.
it's the same words again and again and again.
Yeah, exactly. Which is why you typically don't have a bunch of these things. The reason I'm showing false and false is so that when you do x is 10, x greater than 5, and x less than 20, what should it be? True, but that's the same as true and true. But if we did this, if x is less than 4, what should we get?
False.
Because we have true and false. What if we did, so if x is 10, x is less than -9, -5, we're still going to get false because x is 10 and it's greater, so you have a false and false. Does that make sense? Instead of just having true and false and or and this and that, throwing something like that makes it easier to understand, right? Because you know, well, of course x is less than, 10 is not less than 5, nor is it less than 4, so that whole value is false. However, if we do x is greater than 5 and less than 20, that works. But we can also do what's this? Because that is true or true. Comes out as true.
Someone is
What?
nothing. I said I thought you just did that, but it's fine.
Okay. Oh, I think Will. I thought I had a noise to play whenever someone left.
Also,
Hey, Will.
Hi.
What's up?
this is a weird question, but can I get an ice somewhere? Because I did my foot yesterday, and I did not take what I needed to, and now it's in the
Yeah, the nurse's office has it. All right. Does anyone have questions on that? All right, so we were going to scroll down. We did all that. There's also, so we went over or, and not. So not true is, not false is, that's, yeah, there you go. True or true is, false or false is, true or false is, false or true is, yeah.
Wait, so
What?
why is if there's an or, why is it
For which one?
Or the other.
for the like true or false?
So so if you had to pick between 1 or a 0, okay? Are you a 0 or a 1?
Yeah.
So that's why it's true. Can 1 be 0 or 1?
Yeah. Okay.
So it's, can you both be a boy or girl?
Yeah.
Can you both be boy and girl? Can you be, so that's exactly why that's why having the or in there differentiates it between a boy or girl or boy and girl.
Can you ever have a false in an or statement? Or not?
Well, these are the only four possibilities for ors.
Oh, okay.
Yeah. So again, can you both be? Could you be pink and blue? But could you be pink or blue? Yeah. Yeah. Okay. All right. So now we are going to jump into actual code and the syntax of an if statement. So I've just spent about 40 minutes on this so that when we get to the actual if statement, it makes more sense. So everything we've gone over, we've done Booleans, which can only be true or false. We've had, and I didn't actually say these, this is a logical operator, and, nor, and, not, and, or are all logical operators. This is a relational operator because it determines the relationship between two things. Does that make sense?
Yeah, when do you use these?
When do you use what?
Like, why would you ever want to run false and false in a shell?
You probably wouldn't.
Right. Like, what are we going to use this for?
Well, you need to understand that.
Oh, just like understanding it?
Yeah, so. Now with this code, I know that no matter what, if this is true, if this expression is true, the number is positive. Right? So if this is true, x is positive. So you need to know what does it mean to be true versus what does it mean to be false. What if I did what's the answer, Asher?
X is positive?
Yep. So you need to be able to know that the not before a false statement makes it true. So that's all the last 40 minutes have been, is drilling in trues and falses, and now we're actually getting to the if statements. So in order to write an if statement, you need if, shocker. You need the expression, whatever it is, ending with a colon. Then notice when you hit enter, it does not go to the far left of the screen. It actually goes 4 spaces in or 1 tab. Now the code we write here will only happen if this is true. If this whole expression is true. So we can go x is greater than 10. Does that make sense? Any questions? I know people do, so I'm going to take a swig.
What kind of a drink is that?
A strawberry dragon fruit refresher.
That's a weird combination.
My wife surprised me and dropped it off. So,
Is it good?
very refreshing. Aha. Everyone understand this?
Yes. Yes.
So if I type in x is 100, what will happen?
X is
So we'll see x is greater than 10.
You should do an else so that.
We're not there yet. We're not there yet, Ash. You're getting ahead of me. So x is greater than 10. Now I'm going to do this. Does that make sense? Questions? Will, how you doing? Cool. What if I did this? Well, that's kind of lame.
That's why you gotta do things.
So, okay. So one thing. Okay. So if x is greater than 10, print x is greater than 10. Does that make sense? So no matter what, this line of code will get ran, right?
Yeah.
Will this line of code get ran?
No, not necessarily.
Not necessarily. It depends on what? Depends on x, whatever x is. If x is 10, will this run? What are you talking about?
It's not greater than just.
There you go. It's not greater. So what can we do to this to make it greater than? What's one thing we can do? There's actually two ways you can do it, but
Add equal sign and the
here you could also do greater than 9. However, is that the best way to do it? Luke, why?
I mean, I just think it makes more sense, I guess, to do it the other way. So not
Now take a look. Can you explain why now? Well, so take a look at this. If x is 9.5, is x greater than 9?
or yes, it is.
Because it's 9.5. But our code says what?
If it's greater than or equal to 10.
So is x greater or equal to 10? If it's 9.5.
Or, no,
Right? So this is true, but it doesn't match it. This is a logic error.
so it's just more mistake.
Yeah. There's more room for screwing things up. So this is one of the times when you gotta like know what your code's doing and know like you gotta be a good coder and you gotta think about how other people might screw your code up. So it's better to do greater or equal to 10 because then it gets rid of that 9.5. Okay? So so let's say x is greater or equal to 10. Let's make this 50. We can, while inside of this, let's say there's a secret number in our video game, right? If they type in, they have to type in the number of hearts they want to start with, whatever. And so as long as they type in a positive number, it doesn't matter, right? They could type in 100 hearts and they'd be awesome. But if they typed in 50, it's a little bit of an Easter egg because I was born on the 50th of October, whatever. I'm just trying to make something up, not the 50th, but 50 is my favorite number. Okay, so you could do if x equal 50, print that's my fave number. And so now watch this. So if we run this, if x is 50. X is greater or equal to 10, that's true. That's my favorite number. And then this is not in the if statement. However, if I change this to 49, what's going to display? X is greater than. Is that it?
And this is not in the other statement.
And this is not in the if statement. Correct. Does that make sense? So this was true because 49 is greater or equal to 10, right? So it evaluated that, that came out true, boom, it prints this. Then it goes to this line. Well, is x equal to 50? If x is 49. Is 49 the same as 50? So then it does not evaluate that. It does not execute this code. It just skips to this part. So this code here will only run if this code runs. So what I could do is if I change this to 50, so what I've done is I've changed 49 to 50, and I've changed this from greater than to less than. So if x is less than or equal to 10, run the code. If x is greater than, or x is the same as 50, print that's my favorite number. What's going to display now, Brandon?
This is not the statement.
That's it? All right. Totally correct. Who can explain that? Brandon?
That's because of the if statement, the original if statement says x is less than or equal to 10,
Yep.
and the other if statement is within, is inside that if statement. And
Cor-
so it's false. So it's not right.
Correct. This is false, so it doesn't execute code. So this right here is false, so none of this gets executed. It's as if it doesn't exist. It skips over all of it.
How can we do not skip it?
What?
How can we not skip it?
This has to be true.
How?
Okay.
So you would just x is greater or equal to 10, then it would work. Brandon.
Or could you also take the second if statement outside of the original if statement?
You could, yeah. So you could do this, which would, and then if we did this, less than, that's my favorite number. So at that point, it evaluates this one. It's not true, so then it jumps to this one. What if we did that? What'll happen? So all I changed was this from less than to greater than. Luke?
It'll print all of them.
Nice. What if... Alright, so you guys seem to be getting it. So we're going to do a little bit more of a concrete example. So I'm going to comment all this out. And we are going to jump down to... I just want to make sure I cover the exact, same amount of stuff. So I have my old code over here.
Oh yeah, how did you do the commenting out thing again?
Same question. I had the exact same question in my other class.
It was this class last one, I forgot.
All the stuff is right here. So to comment out a region is Alt-3. To uncomment out a region is Alt-4. To indent an entire region is Control close bracket. To dedent an entire region is Control open bracket. So format, that's the last time I'm answering that question. All that stuff's in format, So we're gonna go x is int input, please enter a number. And now we're gonna go if x is greater than 0, print x is positive. Now, the next thing, if it's not positive, then it's what?
Negative.
Negative. So we can put, if it's not positive, then anything else they type in we can assume is negative, correct? So that's what else is. Anything, any input, anything that's not in this that doesn't make this true. Come on, scroll. No, just. So anything that is false in here is gets displayed down here. So when we run this, Kevin, give me a number.
Negative.
Negative 2. X is negative. So we'll take a look here. X is greater than 0. Does -2, is that true? If x is -2, is that true? Is -2 greater than 0? No. I gotta give you guys some time to type. Again, all this stuff at the end of class is online. I save it to the student resources folder. So if you take better notes, like just kind of commenting what I say, or right now you can download this and get exactly as it is. However, every time I save it, it's not we can't be working on the same document at the same time, but you can at least see the revisions or whatever. So I'm just saying, I think I like having you guys follow along. It's just those like 30 seconds of me waiting for you guys to catch up. Like, I like filling with noise. So, x is positive. So if x is -2, is -2 greater than 0? No, so x is negative. So I could also type it, so if I don't have, well, if I typed in a word, yeah, I'll just do that real quick. What's wrong?
You put in a string rather than a number,
So I was allowed to do, I could evaluate strings.
but it's not an integer.
There you go. I can't compare integers to a string. I can only compare integers to integers, or numbers to numbers, and strings to strings. So I can't do h greater than 8. Because what does that even mean? I don't know. What?
So to compare those two, could you put in like the integer around the h?
You know, you can't do integer h, because what's the integer version of h? I don't know. It doesn't exist. So, no.
I was wondering if you use the ASCII.
That's what this does. So
Oh.
this evaluates it on an ASCII level.
Oh.
So whatever h is in ASCII must be greater than whatever 8 is, and I don't know. Yes?
Can I go to the bathroom?
Sure. All right. So let's run this. Actually, oops, let me change this back to an integer. So if I enter in 0, wait. 0 is not negative.
But 0 is not greater than 0.
Right,
So
but I can't. So 0 is neither positive or negative, right? So I need another way to. I need another if statement, basically. Now there's two ways I could do this. I could do if x is greater.
If x is equal 0, maybe?
Yeah, that's if x equals 0. Print but then what do I have to change? I have to change something somewhere.
Else.
Not else.
and first,
The first one.
yeah.
Oh wait, no, I'm stupid. Never mind, you're good. You're right. So now if I type in 0, x is 0, neither positive or negative. Now I could, instead of putting this in here, I could put it in here. If x is equal to 0, and then put another else. I could do that as well.
Sorry, could you scroll up for a sec?
Oh, okay.
Does that make sense? So is x, if x is greater than 0, it's positive, which is totally true, right? So then it jumps down here. So if we type in 0, is 0 greater than 0? So we jump down here. Is 0 equal to 0?
Yeah.
So then it will print this. If it's anything besides 0, it will print this. Right? This is a little wordy to do, right? You got to throw in another if else underneath an else. So what we're going to do is instead of all of that, actually, I'll keep that and I'm just going to copy and paste this. Copy, Alt-3, Control-B. There we go. We're going to take this, Control-X, Control-V. All right, this is what we had before, right? Let me show you. Let me know if this will work. What do you guys see?
X is positive and X is 0.
Yep, x is both 0 and positive because of this. Now, with ifs, every if will get ran. You will have multiple, you can have multiple answers for one thing. X, 0 cannot be positive and 0. But is x greater or equal to 0 here?
Yes.
Is x equal to 0 here when I type in 0? So both of these are true, so both of these get ran. If I want to make sure only one of these gets ran, I need to do an EL here to combine else if. Just like we did up here, where we have this. If this isn't true, it goes here, and then it evaluates these two. Instead of having this jumbled mess, we simplify it to this, which makes a lot of sense, right? If it's not this one, it'll go to this one. If it's not this one, it'll go to that one, and it will continue to go down until one of them is true. Silence your phone. Does that make sense? So I'm going to use another example that I think might put it better into perspective for you guys and ladies. So, grades. Can a grade both be an A and a B?
No.
Can you get an A, B on a test?
No.
Well, maybe a blood test, but only
I
one.
thought it was funny.
Okay. I can only tell by your eyes, so if you don't squint in your eyes, I can't tell if you're smiling. So grades is a float because can you get a 99.5 on a test?
Yeah.
Yeah, so we want it to be a float. Input. So now we're going to do if grade is greater than 90, print you got an A. If we just do this, print you failed. Is that true? Is that how grades work?
Nope.
If I type in, if I get an 80 on a paper, if I get an 80 on a paper, I shouldn't have failed. Right? Obviously, you have pass fail, but
Depends on your mom's standards.
well, I guess that's true. Yeah, yeah, that's true. I remember those days. So you failed. Otherwise, you know, I got a 90. Oh, I still failed even with 90. Come on. What do I got to do to fix that?
Oh,
You let's say Ellen
Greater than or equal to.
Greater than or equal to, yep. Okay, well now I also have to work in what happens if I get a B. So what should I do? If grade is greater or equal to 80, right? I'm going to copy and paste this because I'm not lazy. I'm not lazy. I'm efficient. There we go. That's the unofficial motto of this class, by the way. All right. So good. Now I got my code working. I got a 90. How do I have an A and a B? What is going on? Luke, fix it.
But L before the second hit. No, EL.
I was messing with you. That's right. Okay. So now when I run it, it evaluates this is true and then ignores everything else. Yeah. Elif is if this isn't true, it's the way to evaluate to add multiple if statements. Typically you only want if as many elifs and then else. One of the few times where you want elifs, where you want ifs instead of elifs, that I can think of is in your video game. If you want your character to only be able to move up, down, left, or right, you use elifs. If you want them to be able to move diagonally, you use ifs. Because the way we code is if we're hitting up, if hitting up, go up. If hitting right, go right. What happens if you go up and right at the same time? You go diagonal. So that's how you get your character to move diagonally. If you have if up is up, if hitting up, character go up, elif, character hitting right, go right. Whichever one gets hit first, you'll only be able to go in one direction. You won't be able to go diagonal. So in the game we play, our character can move diagonally, but maybe your character in your game is stuck in a maze and you only have up or right, so you don't want him to be able to go diagonally, so you code him in a different way. That's really kind of the only thing that I can think of where you would want to use ifs instead of elifs in this class. In the advanced classes, you have a little bit more, things can be multiple things, especially when dealing with files. But does this make sense?
Yes.
Questions? So I want to do the rest of this. I want to get C and D. What's the fastest way to do it? Someone said copy and paste. So I'm going to copy that, paste, paste.
Now you change the 80 and the grade.
70, 60, C. Do not be afraid to do that on your tests. There's one test, I can't remember if I still give it to you guys, where you have to code all 9 outcomes to rock, paper, scissors.
Wait, seriously?
Yeah. So you just copy and paste them and then edit it. You write one of them and then just copy and paste. So, again, don't be afraid to do that. Now, if we type in a 75, we're only going to get one answer. But if we were to do, again, ifs all the way down the board, and I got an 85, not an 80, I'm going to get a B, C, and a D. Which is not what I want, Brandon.
Wait, so when you have to do a grade is greater than 80 and grade is smaller than 90? Like,
if you were doing just ifs, yeah. So what he's saying is, if we did if grade is greater than 80 and grade is less than 90, you could get away with that. But you'd have to do this with every single one. You couldn't just do it with one. Might as well throw it up here for and grade is less than 100. That should be 90. That's 80. That's 70.
it doesn't look very nice though.
Well,
It's not as efficient.
You do have to take more steps, yeah. And the thing is that it'll evaluate each one of these as opposed to one and then done. So in a computing scale, granted this is very, very, very simple code and your computer can handle it like that, but it may be 2 microseconds faster to do it with just elifs instead of ifs. And if you have really, really complex code or you have stuff that's really dependent on time, like the stock exchange, like being able to buy and sell stocks. My brother worked for a company for a while, and he said, he was telling me that some company or companies paid like tens of millions of dollars to get fiber optic cable put underneath the sea floor to shave off like tenths of a second in buying and selling stocks. So if your code depends on milliseconds and microseconds, yeah, you want the most efficient code possible. But for right now, it's not that big of a deal. But yeah, you could do it this way, and you get the same answers. So 75. Wait, what? Oh, because if, yeah. So it's better to use elifs.
Wait, why didn't that work?
What it did is it evaluated this as its own thing, this as its own thing, this as its own thing, these two together. So this was an if.
Oh right, you have to do like.
It evaluated those two as one brick, and we don't one block, and we don't want that.
That should not happen.
Well, it did.
Why is it like that?
I don't know.
It's not like that.
Maybe you did it wrong. All right, real quick. So I got 5 minutes, and this is the last thing. I got to this in the other class, and I want to get to it here. So you can do this with inputs. So this is exactly how like you log into an website. So we're going to do name is input. Please enter your name. Who wants to be our guinea pig?
Me.
All right. If name equal Does that make sense to everyone? We're just going to run this. Oh, that didn't work. Why not?
Because you entered the wrong name.
I entered the wrong name. Correctamundo. So let's run this again. Yay! Oh.
Capital.
Right. Remember, code thinks capital letters are different than lowercase letters. Do humans necessarily?
No.
No, if I text one of you guys and I don't capitalize your name, do you think it's a totally different person? I hope not. Do you, Will? No? Okay, smart man. So, it's a totally different name, totally different thing. That's why you can have a lowercase and these are two different variables. Oh, well, I did. Okay, forget that. So, yes, Luke.
I don't really remember, but can't you put dot lower after the one?
Yes, but we haven't covered that yet. But yeah, that's what you can do. So what you could also do here is, if I wanted the code to match Lorian with an uppercase and Lorian with a lowercase L, what do I add right here?
Or.
Who said or? What do I type? Or
On the, quote, one single quote, and lowercase letter.
very close. You do have to type in name equals. You have to have a full expression
Wait,
here.
wait, equals.
Thank you for this. Thank you. I was wondering if anyone was going to get that. You do have to have the full expression. And I have 3 minutes, and I really want to get through this. So we're just going to do the same thing with password. Actually, you know what? I shouldn't be rushing you guys. How are you guys feeling?
I don't want to do that again.
Yeah, you'll wanna cycle through the Elif part. I'm gonna have to upload like 2 1.5-hour lectures, so I don't think it won't be done right after school. But by the end of the night, it should be up. Do you guys have any questions? Okay, I'm good to continue.
Yes.
All right, so again, we're just gonna do the same thing with password. Is input. Please enter password. If password equals swordfish. Oops. A little bit of a typo. So let's just make. Oh, no one caught that.
Is it equal something?
It's supposed to be equal, yeah. So please enter the name. Lorian. Access granted.
How
So
do you cycle back if like they type the wrong password? How do you say incorrect password? Try again.
you need a loop, and we're not covering that yet. So right now, just if statements. They get one shot, one opportunity.
I don't even have an idea of how to do that.
Oh, well then good.
What does a loop do?
It cycles through code.
Well, I know what a for loop does, but how do you do that?
We're not doing it for it. So don't worry about it. We'll cover it soon. So the bell's about to ring. So over the weekend, you guys have the test or the quiz. Wait, Will, did you hear?
Would the following students please come to the front?
Did you hear the
office?
announcement at the
Charlie
beginning of the
Andrews,
class about the
Nadir,
quiz?
Sumagulov, Jane
I hear
Wong,
a part of it.
Jaden Paulson,
Okay.
Michael Bush,
Well then, stay on, and I'll
Thomas
talk to you
Smith,
afterwards.
please be on alert.
So you guys have the quiz, and I'm going to put online some practice problems with if statements. Actually, not practice problems. In the book, there are sections where it shows code. So starting from page 30, where it says Alice, hello stranger, or whatever, I want you guys to hand type this code. So, Will, I'll go over that with you. Those of you online, I can't see.
Will those instructions be on campus?
Yes, they will. So all I want you guys to do is to go through and type that out and make sure there's no errors. Please don't copy and paste it from the book. I really don't know if you do that, but it really won't help you if you do that, because you need to get used to writing this sort of stuff. And then starting Tuesday, I'll actually have some coding problems for you guys to work on, and probably in class. So you guys, if you guys do run into issues, you can talk to me and I'll walk you through it. But as for now, just the quiz, and again, I'm going to make a new assignment for you guys to put stuff up aligned to. Again, if you feel like you did great on the quiz, upload the code you've already written. You do not need to redo it. If you want to work on it, I also have your actual grades here if you want to come take a look. But yeah, other than that, class is over.